Hey there, awesome physics students. I wanted to do an example problem of analyzing a circuit. What we want to know is, here's our example circuit. It's a 12 volt battery and it's got a 3 ohm resistor, that's resistor R1, and then resistor R2 and R3 are 2 and 4 ohms respectively. And what we want to know is we want to know everything about this circuit. We want to know the total current. We want to know the current going through the first resistor. We want to know the current going through the second and third resistors. We also want to know the voltage drop across the first resistor, the second resistor, and the third resistor. Okay, so that's V1, V2, and V3. We want to know everything. Now, when you're analyzing a circuit, the most helpful thing to do to begin is to remember how current and voltage behave in circuits. And then you can instantly identify some of these are going to be the same and some of them are going to be different. And some of them you can just identify by looking at the circuit and understanding without having to compute anything. So that is the very first step, and it's very important that you do this so that you get a good intuition for how circuits work instead of just computing things and not understanding what any of it means. Okay, so the first thing that we can notice here is that the voltage across the battery is 12 volts. And if you recall how you measure voltage, you take the two voltage probes and you place it across the battery. But if I move this on this wire, this voltage doesn't change. I could move this here without lifting it. And I notice that's the same as the voltage across R1. So that tells me that voltage 1 is going to be the same as the voltage of the battery. That's 12 volts. I can just look at it and notice that. The other thing is that if I measure the voltage across R1, I can also move it over here, and that's going to be the total of the voltage across R2 plus R3. So I know V2 and V3 are going to add up to give me 12. The other thing I'm going to notice is that I have a current coming out of the battery. That's the total current. And this current is going to travel here until it reaches this node here, and it's going to split. It's going to split into current 2, I2, and I1. So I1 is going to flow through R1, and I2 is going to flow through R2, and it's going to flow through I3, or R3, excuse me. So I2 and I3 are going to be the same current. Okay. Now I can't just look at it and notice what it is, but I at least know that these two will be the same. Okay. And then the other thing is I notice that I total is going to be I1 plus I2 because remember, whatever goes in must come out. That means that whatever's coming out has to be equal to whatever went in. And so that these are I1 plus I2 or I3, same thing. If I add these two, I'm going to get the total. Okay? Now we can go ahead and begin. Now that I know, first of all, let me start with this, the knowledge that the voltage across R1 is 12 volts. So I can use that with, I'm going to use this delta V is equal to IR. I'm going to use this, I can use this as a total or I can use this on individual components. I'm going to use this over and over again, this Ohm's law. Let's use that first on R1. So this tells me that if I want the current I1, that's going to be delta V1 over R1. But I already said delta V1 is 12 volts, and R1 I know is 3 ohms. So 12 divided by 3, that's going to give me 4 amps. So that tells me that I1 is 4 amps. Okay. I can also look at what happens here. The total voltage across here is 12 volts as well. But I noticed that I can combine these two resistors using our series combination knowledge about how resistors combine in series. These two are in series with each other. So the total resistance for that, for 2 and 3, is just going to be the resistance of 2 plus the resistance of 4 ohms, which is going to be 6 ohms. And so I can get the total current I2 that's just going to be the total voltage across this, which I already decided is going to be 12 volts based on my previous argument, divided by the total resistance for this branch of the circuit. Well, that's just 6 ohms. And so 12 divided by 6 is 2 amps. So I know that this is 2 amps and this is 4 amps. So let me put that over here, 2 amps. And we decided that I2 and I3 are the same. So that tells me that the total must be, well, if 4 goes this way and 2 goes this way, then that means that whatever comes in must be equal to 6. So the total current must be 6 amps, right? That's 4 plus 2. All right, so we're filling this in pretty nicely here. We can again use Ohm's law on these two to get the voltage drops across these. Now notice that I can't just look at these and say, oh, the voltage drop across R2 is blah. The total voltage drop here is 12, but I'd have to lift this probe. If I were thinking about how I measure voltage, I'd have to lift the probe and move it here to measure the voltage across R2. So that's not going to be the same as 12. However, I can use this relationship again, Ohm's law again, on that particular resistor. And so the way to do that is to say that delta V2, that's for R2, is going to be the current flowing through that resistor, but that's just 2 amps. That's I2 times the resistance R2. So if I run this on that, then that's going to be 2 amps times the resistance 2 is 2 ohms. That's going to be 4 volts. Okay, so the voltage drop across this one is 4 volts. Now, at this point, I can also quickly answer V3. It's going to be, I can just look at this and note that that's got to be 8 volts. Now, how do I know it's 8? Well, I know that this is 12, so to go from top to bottom, that's going to be 12 volts. And this from here to here is 4. That means there's 8 left over. And so I can just fill that in, 8 volts. I can also compute it this way. So I can also say, well, delta V3 is just going to be the current through 3, I3, times the resistance here, which is R3. So that's just going to be, well, I3 we decided was 2 amps, and R3 is 4 ohms. And so when I compute that, I get 2 times 4 is 8 volts. Well, that's exactly what I would get if I did it this way. Many times it's nice to just fill it in based on what you know, rather than just computing things, because you know, sometimes it's convenient to just compute things because you feel like you don't have to think about it. But it is important to think about this so you understand what the difference between current and voltage is. And the only way to do that is to just practice. So please rely on your knowledge of how current and voltage behave. Also notice the way I spoke about current and voltage through here. I always talked about voltage across two elements. Okay, the difference, because we're thinking about the voltage difference from one point to the next point. That's connected with potential energy. Then when I talk about current, I always talk about the current through something. That is flow, right? Current is flow, so current passes through something. The current through this has to also go through this, and that's a nice reminder, so careful with your language as well. All right, I think this wraps it up for this problem.